All right, so what we're talking about today is limits involving infinity. So we're also going to be referring to the principle of dominance worksheet. The principle of dominance worksheet, that is on the back of worksheet 5 for us, okay? So the first question is, what is the limit as x approaches plus or minus infinity of the function 1 over x? So this question seems crazy, okay? But I want you to think about what this is really asking. The limit is basically what's the y value? Like what does the y value get really close to? And then x approaching positive infinity and negative infinity. Well, positive infinity is way over here on the x-axis. Negative infinity is way over here on the x-axis. So it's basically saying, what is the y value on the very right or on the very left of this function 1 over x? 1 over x, I want you to realize what it looks like. So the graph of 1 over x looks something like this. So you're going to fill that in. You should know this, and if you don't, then know it now and put it in your head forever. So 1 over x is a hyperbola with these asymptotes. So asymptotes that we're not going to cross going up or down. To the right, we get closer and closer to that asymptote of the x-axis, and to the left as well. So what is y approaching? That's the question. What's y getting closer and closer to? On the very right, it gets closer and closer to y equals 0. Because what is the x-axis that we're getting closer and closer to? It's y equals 0. Same on the left, y equals 0. That's why the limit as x approaches positive or negative infinity of 1 over x is 0. Okay? So what would this be? I know you see the answer. But the reason that this is 0 is because, well, what's 2 over x? Well, you would just take this function and you would multiply the y values by 2. So you'd stretch it up and down. So if it's stretched up and down, does it matter what happens on the right and the left? Does that change? No, you're still going to get closer to 0 on the right side because that's positive infinity. And then what about the next one? I want you to try it. What about the next one? I want you to try it. I want you to try all these, and I want you to think about them before I show you the answers right now. And they're all 0, right? Because what happens when you stretch it by a lot? Nothing on the right side or the left side. What happens when you flip it? So a negative, or actually negative infinity means the left side. What happens on the left side? It still goes towards 0. What happens when there's a negative? Well, when there's a negative, you flip over the x-axis. So if we flipped this over the x-axis, this would come down here, and this would go up here. But this would still go towards the x-axis. That would still go towards the x-axis. So it's still 0. It's still 0. It's still 0. What about this one? I want you to think about it, 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 and realize that this is basically infinity squared, right? If we were gonna plug it in, it'd be like infinity squared. How come 2 divided by infinity is 0? We talked about that when we talked about this stuff. And we said, okay, what happens when you divide by 0? What happens when you divide by infinity? And we referred back to this. Remember what happens to the numbers on the right side when you're dividing by infinity and your number gets bigger and bigger. So think about what happens on the right side that we did in class. Okay? Okay, so this is helping us with the principle of dominance. Let me tell you really quick about the principle of dominance. Basically, the principle of dominance is saying that if you have something like, so this is part of your homework, okay? So if you have something like this, the principle of dominance is saying, okay, you can reduce. So there's an x on top, there's an x on bottom. If you were to get rid of this, because like infinities are so big, we don't need to deal with these other like numbers that aren't infinities. So basically, if we reduce just this part, we would get 2 over 5. The answer is 2 over 5. Actually, is that a positive? Yeah, that's a positive infinity, so the answer is 2 over 5. Let's look at this one. So this is negative infinity, so if we reduce, we get 5 over 6, but then negative infinity would be negative 5 over 6. I'm going to skip a little bit. So let's say we get to this one. This, if we reduce, we get 3 over x. 3 over x would be 3 divided by infinity. So even though it's negative infinity, 3 divided by any sort of infinity should give me 0. So that's the principle of dominance, and then I wrote a gist of it over here. So if the bottom is more, so the top is less than the bottom, then we're dividing by infinity, we get 0, any sort of infinity. If the top and bottom are equal, we take the ratio. If the top is bigger, then we reduce, and then we can basically plug in and see what happens. Okay, so the principle of dominance is when we look at it, I'll skip to one like way down here. When we look at it, this is really negative x squared over 7. So negative x squared over 7, when we just take the principle of dominance, and then there's a negative negative, okay, so it's x squared over 7. Well, what's x squared over 7 if we plug in infinity? Infinity. So infinity squared is infinity, so the answer for 26 is infinity. You try them, and we will answer all of these tomorrow. But these should be like relatively quick. You can just write on the paper. Okay? All right. So moving on. Right here. So what about when we have something like this? So I want you to really think about what this means. So as x goes on the right side of the 0, okay, I want you to look at the picture again. X equals 0 is here. The right side is right here. So what's happening to the graph on the right side? It's going up, up, up. That's positive infinity. It's just getting higher and higher, that y value. What's happening on the left side? It's going down, down, down. That's negative infinity. So that's why over here on the right side is positive infinity. And then on the left side is negative infinity. And then I'm going to show you the rest, but really you should try them, okay? So 2 over x, it's the same picture. Remember, it just gets stretched vertically. So the right side is the same. Again, stretch vertically, the left side is the same. What does this really mean? 1 over x squared. Well, think about 1 over x. So 1 over x is, so it's infinity, like times infinity, basically. So that's why you get infinity. What about this? Well, let's think about it. If we plug it in, what happens? You get a 0 minus, so the left side of infinity, but you square anything. When you square something, you get a positive. What is this again? It's positive. So why is this positive? Remember that? Remember the picture? That's why it's positive, because in the picture, we're looking at the right side of the 0. So we always imagine this as 1 over x. So here's our gist. So the limit as x goes to 0 on the left side of any number over x is going to be negative infinity. But the limit as x goes to the right side of any number over x is positive infinity. But see, if that number is negative or if that number is positive, that's when things change, right? Because when that number is negative or positive, what that means is the graph flips. It like flips upside down, like, right? North and south, it flips. Okay, so you're gonna try some. I just showed you all the answers, but you're gonna try some. You have to try it yourself, honestly, and then I'll explain. So you try first, and then, okay, so really this is a number over, this is basically a 0 plus, this is the principle of dominance. And then this is, okay, I want you to think about this. So if you plug in 0, cosine of 0 is 1. And then if you plug it into here, you get that. What is that? It's 1 over x on the right side. Okay, then there you go. Okay? And then this is going to be, okay, you plug in 0 on top, you get a 1. You plug in 0 on the bottom, 1 over 0. Guys, 1 over 0. If you plug this into a calculator, what does it say? It says error, domain error. This does not exist. Okay, this is different than this one. This is 0 on the right side. This is just 0. So the difference between that would be, what is the limit? 0 on the right side. Oh, it's positive infinity. What about 0 on the left side? Oh, it's negative infinity. What about 0? It does not exist because the right and the left are not the same. Okay, so it's very different when it has a little plus or minus and when it doesn't. Ooh, sorry. Sometimes it does that when I don't touch the computer. Okay. And then what about on the left side? Okay, let's plug it in. Let's see what happens. So 0, plug into the top, you get a 1. This, you plug into the bottom, you get a positive, because anything squared is positive. And then you get infinity. Okay? Try 5 through 10. Do it, do it, do it. I'll show you why those are the answers. Okay, so number 5, you have a -4 over, and then you have negative infinity. So I really showed all my work here, okay? And then number 6, even though that should be a negative because it's 0 minus, that's a -1, so that's positive infinity. So you see how this works? And then right here, I plug it in, and I go, okay, that's a negative, but then that's a negative, so that gives me positive infinity. Same thing over here. I go, oh, that's a negative, but I do it to the 4th power, it becomes positive, and then the -12 divided by x on the right side is going to be negative infinity. Okay. Over here, we have basically principal dominance first, so we have to reduce first, right? So reduce, you get this, and then this, we know from our picture, is going to be negative infinity. I say that we know from our picture, but you do know from the picture, right? So remember, what happens when it's negative? It flips upside down, and then that's how we know this becomes positive on the left, and this becomes negative on the right. So we always have to think about, like, why is this true? In a graph, why would this be true? And then this one we reduce, and then you get that. There you go. Okay? Okay, the next part is really kind of weird and tricky. So these two are very interesting. So highlight them, please. So what about as we go to infinity for sine? So I want you to think about what the sine graph looks like. This is what a sine graph looks like. It starts at 0, 0, it goes up to 1, down to -1. So generally this is what it looks like forever and ever. And then on the very, very right side, it just goes forever and ever and ever. Okay? So basically, sine of infinity, which is on the very right side, is a number that oscillates. Oscillates means like going between. So oscillates between -1 and 1. It just keeps oscillating between -1 and 1. And we would write it like this, right? In the right notation, we would write inclusive of -1 and then ends at +1, also inclusive. So we have this notation. So really, there's two answers. The best answer is that this is this answer. So it's a number, oops, sorry. So it's a number that oscillates between -1 and 1, and then we say that does not exist. Okay? So if you have this, that's the answer. But if you don't see that, then we have to say it does not exist. Okay? Example 12. So the limit as x approaches for tangent. Okay, I want you to think about what a tangent graph looks like. Remember, it goes like this, and then again, and then again, and then again. Well, as we go to the right, sometimes the answer is negative infinity, sometimes it's 0, sometimes it's positive infinity, sometimes it does not exist. So we have to say the answer does not exist. Okay? I know that those are weird. Okay, try the other ones, and then check the other ones. So you see how this one, what we talked about already, oh, that's a number. I don't know what number that is, but it's a number actually, a number divided by infinity. That's 0. What about this? Well, same thing, right? Cosine is also oscillating. Okay, what about tangent? Well, it does not exist divided by anything, it still does not exist. And then what about this one? Well, let's plug it in, let's see what you get. So this becomes a 0, this is -4, so 0 minus 4 is -4. Okay, that is day 1, and then you should pause, and then tomorrow maybe you won't.